Hello, welcome. Let's try to solve a Leetcode problem 698. Partition to k equals some subsets. So let's first try to understand the problem. Yeah. So for this problem, I'm gonna use the first example. Yeah. So for the first example, basically we're gonna solve such problem by using backtracking. But backtracking may cause time limit exceeded. So for me, I'm gonna use bit mask. So it is called bit DP. So for the bit DP, I'm gonna have initial state, and if I reach the final state, I'm gonna return true. Otherwise, I'm gonna return false. So what is the initial state? So for the initial state, I'm gonna set all the bits of those numbers to be 0. So this is gonna be the initial state. So let me make a drawing here. So for example, we have the number 4, 3, 2, 3, 5, 2, and 1. And our target is the sum of them. 20 divided by 4, it is 5. So I'm gonna reach this target value. So from the beginning, I'm gonna set all the bits to be 0. Yeah, so for my state, I don't have the low bit or high bit. It doesn't matter. I just set it like this. Now I'm gonna loop through the numbers one by one. I can make the numbers sorted, or I will make it randomly like this. It doesn't matter. So what if I just make it like this? I will not sort the numbers. If I sort it, I maybe speed up a little bit, but it will have no influence. Yeah, because the time complexity basically is gonna be n times 2 to the power of n. So this n gonna be the length of the nums. It's gonna be 16. So 16 times 2 to the power of 16. So basically this is gonna be a small number. So it will have not a big difference if I sort the nums or not. But firstly, I'm gonna solve it without sorting the nums. Yeah, so the idea is that I'm gonna loop through the numbers one by one, but I'm gonna use the bit as my state as a visited set. So the initial state gonna be always be 0, and then I'm gonna try to visit the numbers. So for example, for this number 4, if this 4 is visited, yeah, so I'm gonna set this 4 to be 1. Yeah, so this 4 would be 1, and then I'm gonna loop through one by one until I find a possible answer. Maybe it is this one, and I'm gonna set this 0 to 1. This is not yet finished, and then for the DFS function, I'm gonna loop through the next. Yeah, next maybe 3. I check a 3, and then I find a 2. I've already found another answer because it equal to 5. 3 plus 2 equal to 5. So I set to 1 here, set to 1 here. Next, I will use another for loop. So I'm gonna start from 3. Yeah, set to 1. And if this is 5, it is not the possible result. Yeah, I'm gonna check the next one. Here, go backtracking, and I'm gonna check the next one. Gonna check this 2. 2 is a possible result. So the sum of them gonna be 5. And finally, I'm gonna set the final this bit to 1. And this 5 is also the result, equal to 5. Yeah, so if I can reach a state like this, I can set all the bits to 1. So my final bit gonna be 1, 1, 1, 1 like this, but it can represent it by number. So it's gonna be 2 to the power of n minus 1, and this n is 7 because there are 7 numbers. So it means 2 to the power of 7 minus 1, and it's gonna be the binary bit of 1, 1, 1, 1, and 1, 1, 1. Why are we gonna use the bit instead of using a visited set? If we are using the visited set, we cannot use the dynamic programming, and we cannot store all the state inside a cache. But if we use the state, yeah, I mean we can store it inside a cache, but it will have no influence. But if we store the state inside a set, and this state is gonna be just a number, it can be 6, 7, or any kind of numbers, because this binary number gonna turn to an integer, digital number. If we turn it into a digital number, basically the time complexity reduced to 2 to the power of 16 times 16. It's going to be reduced like this. So this is why we're gonna use a bit mask, because we're gonna turn the 8. If we use a visited set, we're gonna check all those numbers. But if we use a bit mask, if we use a state, if we use the bit dp, we just use one number, and this one number can represent all the possible results. So this is why it is so fast. Now let's try to use another example. Maybe let's try to use 1, 2, 3, and 4, and this case is 3. Yeah, maybe let's change a little bit. Maybe I'm gonna change this 1 to 6, and this k maybe to 2. Yeah, so the sum of them are gonna be 14. 14 divided by 2 is gonna be 7. So I need to find a target of 7. So I'm gonna prepare the bit mask. It's gonna be always 0 at each bit, and then I'm gonna check one by one. So this one I'm gonna set it, and then I'm gonna check the next one. So 1 plus 6 equal to 7. Yeah, I'm gonna set it. It means I've already found one. Yeah. Now what do I need to check again? I don't need, because I've already found 7, and I'm gonna iterate. So this one has already been visited. Yeah, and this one not visited. So I set it as 1, and finally I'm gonna set this as 1, because I've already found the answer. Yeah, but but the problem is, when can we set this bit to 1? Definitely, if this value is less than 7, we can set it to 1. If it plus this value is less than or equal to 7, we can set it to 1. Yeah, but when should we go to the DFS? If this 1 plus 6 equal to 7 equal to the target number, so we're gonna start the next recursive function. We're gonna call the DFS. Yeah, if we didn't, we're gonna go through to check the next. Yeah, now let's go back to the coding part. So I'm gonna have a check. So it's gonna be the sum of the nums. So if the sum of the nums modular k not equal to 0, so I'm gonna return a false. Otherwise, I have a target value. So the target should be the sum of the nums modular and divided by k. Now I have my target, and I just need to return my DFS. So the DFS would be a state, as the bit manipulation is going to be starting from 0. It means all the bits going to be set to 0 for all those numbers, and then I'm going to prepare a target value. So from the beginning, I'm going to set it to 0. If this 0 equals to target, it means I will go to the next. Yeah, it means I've already found one set. So for example, I'm already found one set. I'm gonna check the next set if it is possible. Yeah, now let's go to the DFS part. So we're gonna define a DFS function. It's gonna be the state and with a total value. So now we are going to check the state. So if this state is equal to 1 left shift with n minus 1, it means I'm going to set all the bits to 1. So I'm going to return a true. But what is this n? So this n going to be the length of the nums. Yeah. Now we are going to use a for loop. This for loop is used to check all the bits of the numbers. If it is a 0 or 1, I'm going to check it. So for I in range of n, yeah, I'm going to check this bit. So how can I check this bit? I'm going to use the previous state. So this is my state. Yeah. So this state gonna use add. So this state would add my current bit. So this bit is going to be at the ith bit. So this I would be left shift. So we're going to use the left shift with I. Yeah. So this means we're going to set the first bit to 1. And this one, we're going to check it with the state. If it is equal to 0, this means this bit is not set. So we're going to set this bit. Yeah. If it is a 0, so we're going to set this bit. and we're gonna update the state to new state. We're gonna update it to the new state, and the new state would be this state, and we're gonna change this add to all, because add, it means definitely this is 1, this bit is 1, but the bit at the state is 0. If it is 0, we're gonna set it to 1. So the new state, we're gonna set it to 1. Here we're gonna use all, and here is add. Yeah. Now I'm gonna prepare a temporary variable as a result. So the result would be equal to the total. Yeah, the total is just coming from 0, and then it's gonna be bigger and bigger. So the total would plus the nums I. So if this if this total plus the nums I are less than the target. Yeah. So if it is less than target, we're gonna still go for the DFS. Yeah, because we're gonna check the next one. So else we're gonna set it to 0. But there are only 2 conditions to check: if it is less than target or it is equal to target. How can we control that? So we can control it from here, and from here we're gonna check the total plus the nums I should always less than or equal to the target. And then if it is, so this means if we can set a bait, and also the total plus this numbers is less than or equal to the target, so we're gonna set the new state, and we're gonna set a new result, and then we go for the DFS. And then we go for the DFS with the new state and the result. Otherwise, we don't need to check the DFS. Yeah, so this is the only conditions here. So this means if it is less than, we're gonna set it as total plus nums I. If it is equal to the target, we're gonna find the next DFS. So the DFS, so for the result, gonna be set to 0. Yeah. So for example, for this example, if we find a total sum of 5, so for the next one, we're gonna set it as 0. Yeah, so this is why we're gonna use this result. Yeah, but from here we can check it. Yeah, because this DFS just means we're gonna check and check until we find a variety, until we find true, until we find all the possible cases. So for example, we're gonna divide it into 4 subsets. This is just to check if we can divide it into 4 subsets or not. If we didn't find it, we're gonna return a false. And why it works? Yeah, because from here we're gonna check all the values would be less than or equal to target, and also from here, definitely we are sure. From here we are sure there must be a target. Yeah, so this target is equal to the sum of nums divided by k. Yeah, this means it may have a target, but we are not sure. Maybe we can find a true find a result, or maybe not. But we have to try all the possible cases. And from here, definitely we're gonna check if it is less than or equal to the target. So if it is less than, we're gonna set the result to the total plus nums I, because we just need to find more numbers inside the nums set. But if we find this number, so we're gonna set the result to 0, so we're gonna find again. And how many times we need to find? We just need to find k times. But why don't we need to put a k inside the DFS? Actually, we don't need it. We just need to check if we can find it to the final state. So here, this state, yeah. So this state just means if we can find a final state. So this state just means also the total, yeah, should be equal to 0. Yeah, if you are not believe it, but actually we don't need it. This just means if we set the bait, and this total has already become 0, we don't need to check it. Yeah. Now let me run it to check. As you can see, it works. Now let me submit it. Yeah, this is a time limit exceeded. yeah, normally I think it should also work. Now let's just try to optimize it. Yeah, normally I think it should work. Yeah, let me try again. Otherwise, we're gonna optimize it. Yeah, I think it's unstable. Sometimes works, sometimes not. But let's just yeah. But let's just optimize it. What if we just sort the nums? So we're gonna sort the nums. Yeah, we're gonna do some trimming. So after we sort the nums, here we can check it immediately. So if this total plus the nums more than the target, so if it is more than the target, it means we don't need to check it because the number has already been sorted. For the next number, it's gonna be bigger, so we will not check it. And from here, we just check the new state. Yeah, so if it is 0, we're gonna set it to 1 for this bit, and we're gonna prepare the result, and we're gonna check it. Yeah. Yeah. Let's just try if it is a little bit faster or not. Yeah, let me try to submit. Yeah, it didn't work. Why? Because we didn't use DP. Because this is a DFS. Actually, we need to use the cas. As you can see, it is a little bit faster because there are 45 testing cases passed. But we didn't use the cas. If we didn't use the cas, the time complexity would not be n times 2 to the power of n, because it's gonna be like a backtracking. If we want to use the DP, we have to use a cas. Now let me submit it. Yeah, as you can see, it works and it's pretty fast. And the time complexity is n times 2 to the power of n. Yeah, you may consider maybe we're gonna use this total to calculate the time complexity. Actually, we don't need it because this total is decided by the state. So for example, we have a, yes, let me use an example from here. So for example, we have an array of 1, 2, 3, 4. Yeah, but if we can set the bit like this, here we're gonna set it 1, here 0, and at this position we're gonna set it 1 and then 0. So this means the total is decided by this state. If we set it 1 and 1 here, basically this number is gonna be 4. So this means we don't need to calculate this total for the time complexity. Yeah. Now let's just go back to the previous method. Actually, it also works because we just forget to use the cas. If we use the cas, it should also work. Yeah. Now let's go back. Yeah. Now let's just use a cas. If we use a cas for the previous method, we don't need to sort the nums array. It should also work because n times 2 to the power of n should always work. Yeah, because the time complexity is okay for this kind of method. Thank you for watching. See you next time.